Salam everyone. So today we'll do a quick lab by cyber defenders called the Oski Lab, and this lab is intended to test our threat intelligence skills. All right. So we have 8 questions to answer. So let's read the scenario first. Okay. The scenario says the accountant at the company received an email titled "Urgent New Order" from a client late in the afternoon. When he attempted to access the attached invoice, he discovered it contained false order information. Subsequently, the same solution generated an alert regarding downloading a potentially malicious file. Upon initial investigation, it was found that the PPT file might be responsible for this download. Could you please conduct a detailed examination of this file? All right, so let's answer the question based. First of all, of course, you need to download the file and the lab file, and and extract it with the password, and you will find a hash. Actually, this is the hash of the malicious file. You just can copy that. All right. So after you extract it, and let's start answering the question. So to effectively categorize and understand the behavior and intent of this potential malware, it's crucial to identify its family. What's the name of the malware family for the malicious executable found within the PPT? Well, so for this question, we can use, virus total. We can just paste the hash here, and we can have some idea of the family. So you can here see the crowdsource IDS rules, um, file executable protocol. Okay, we can see here match rules for there's something called Stealth, family called Stealth, C2 check-in, Stealth requesting browser. So this could be the name of the family of the malware. But to double check also, we can use sites like URL house, which is also used to check you know hashes, URLs, domains, etc. All right, we can just paste the hash here and search. Okay, so as you can see, we have the malware. We have the malware URL. We pasted the hash and we have some tags, exe, mark stealer, and as you can see, we have stealth. Okay, let's click. So as you can see, we have the signature is stealth. So we can assume that stealth is the name of the family to which this uh, malware belongs. So we can write here stealth. All right, correct. Question number 2. Determining the creation time of the malware can provide insights into its origin. What was the time of the malware creation? So we can answer this easily by going to Aristotle. We can go under the details. All right, we have the basic properties here. And we have here, of course, if you go down, 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 maybe you can look for the creation time. Yeah, as you can see here, history, creation time, first in the while, first submission. So this is the creation time. Just can copy this and paste it. All right. Okay. Doing the format. The format might be wrong. Yeah. Sorry. Correct. Question number 3 says identifying the command and control C2 server that the malware communicates can help trace back to the attacker. But the C2 server does this malware in the PPT communicate to? So the virus total, of course, we can go to relations and we can look at the contact URLs. So the URLs that this malware is trying to contact to, as you can see, we have two. We have this PHP URL and the SQLite DLL. But here, as you can see, we have an APHP format. So we can assume it's actually this one. This is the contacted URL. All right. And we can go here and, okay, let's paste it. Correct. Okay. If you want to double check, also we can use sites like, um, AnyRun, which is also used to make to have basic threat intelligence and malware analysis of the malwares and so on. So as you can see, this is an analysis for the same hash of a malware that we have seen. As you can see, if you look at the HTTP request, it's trying to connect or contact the URL, which is this one, the 171.22.28.221, the PHP file basically. All right, so we can make sure that it's this one. Question number 4 says, identifying the initial action of the malware post infection can provide insights into its primary objectives. What's the first binary file malware request post infection? So they're asking what's the first library or file dropped by the malware request post incident. All right, so we can go here to actually virus total and we can check for the, for any dropped file, for the dropped files, maybe to behavior. So what kind of file does it drop after its first infection? As you can see from the question, we can know it's a DLL file. So okay, we can go here. Okay, collection. um okay, as you can see, file right case. Yeah, so as you can see, some of the file dropped here is this one. This one is the first file that's dropped. And then we have this TMP XML and so on. So, but this one is the first one, SQLite.dll. So we can assume this is the first file that's dropped post infection or post initial infection. So okay, format is like this. Okay, they're asking for this format. So correct. Okay. Question number 5 says, upon examination, the malware it appears to utilize the RC4 key for decrypting a base64 string. What's the specific RC4 key that this malware use? Okay, so for this type of encryption, we can use, for this type of questions, we can use, any run for this analysis, and we can go here to the VPN exe file, and you can go to the configuration. As you can see here, we have the C2 server it was trying to connect to, and we have here, of course, the keys, the RC4 they were asking, which is this one actually. You just can copy it and paste the answer. Okay, just not to waste time. Question number 6 says, identifying an adversary techniques can aid in understanding the methods and advising and devising countermeasure. Which MITRE attack techniques are they employing to steal a user password, okay, or credentials? So we can go back to any run and we can analyze the behavior of this malware. Okay, as you can see here, the processes. First it executes, and then after it executes, of course, as you can see, um it says here, it's load dropped or written executable, still credentials from web browser, and still credential from web browser, still credentials. Okay, actually look like stealing personal data. All right, so we're in between. These are basically two sub techniques, but they fall under this technique T1555, and here we have actually T1552. Okay, so we can assume it's either this one or this one, but since it's related to web browser, as we have read, so it can't be this one T1555. Okay, so T1555. All right, correct. So this is basically the the techniques of the MITRE attack that it is used. Okay. Another question number 7. Malware may delete file behind by the action of the intrusion activity. Which directory or path does this malware target for deletion? All right. So you know that malware, usually delete themselves or delete the file they create just to evade detection and so on. So we need to look for any kind of behavior that related to file deletion. Okay. Maybe here. Okay. As you can see, still credentials. Oski. As you can see, detected by. Okay. Still detected. Okay. Okay, let's rewrite. Okay, so now this one can go here. Can look for any sign of deletion. Yeah, start CMD for self-deleting. Okay, and as you can see here, this is the command line related to this activity. Okay, so they are asking for what? The directory or path. Okay, so it will be actually this one. Oh, sorry, it will be this one. My phone, my PC is out of charge. That's no problem. We'll continue for the people. Okay. All right. So this will probably be the directory. Okay. Okay. Oh, sorry. They need a specific format. It's like this. Yeah. Actually start from here. All right. Uh, oh my days. What's this? Okay. All right. So let's jump this question because they say you have submit too many answers. We have to wait 1 minute. No problem. So, understanding the malware behavior post data exfiltration can give insights into the evasion techniques. After successful exfiltrating of user data, how many seconds does it takes for the malware for self-deleting? All right, as you can see, so this is the command line associated with the self-deleting. So, as you can see here, from there's a timeout of 5 t or 5 seconds. We can assume this is 5 seconds. All right, so just write 5 seconds here. Yeah, so indeed this is the answer. So here regarding the file path, so it's just it's actually this one, but they're asking for the specific format, starting from here. Okay, so anyway, see you in the next one. I hope you enjoyed, and yeah, see ya.